When you see a vector, you notice that it has a tail and the head of it. And so what you see is with this, we have a horizontal component and a vertical component, which is usually x and y. It says quantities such as a force on a velocity involve both, bless you, horizontal and vertical. It cannot be completely characterized by a single real number. To represent such a quantity, you can use a direct line segment or vector. And so you see here with vector notation, for the vector P to Q, right here, this just tells you what the x component is and what the y component is. It looks like coordinate planes. It looks like coordinates that you've done before. Except now we're using these braces on the side, or these brackets on the side. We're going to talk about that it's vectors. And so this number will tell you here how far left and right you go. This one will tell you how far up and down you go. And so it says PQ has an initial point of P being at x1, y1. So there's your starting point. And it ends at x2, y2. Vectors can also be denoted by a lowercase boldface letter by V. And that's usually what you'll see is. And so you'll see something like this. Vector V, which is vector V, which goes to the right 2 and up 3. And so what you're seeing now, guys, is the way you calculated slope. The way you calculated slope, rise over run. Except now we break it up. What's the run, comma, what's the rise? That's it. And that formula will look very, very, very similar. Okay? And of course, one more thing is, what's the magnitude of it? Magnitude is used by two vertical lines on each side of whatever the segment's called. Okay? And so what you'll notice is, this, to calculate it, is going to be something very familiar that you've seen. So let me ask you something, guys. If I have a vector, and it has a horizontal component and a vertical component that meet at a 90 degree, and let's say this is A and this is B, how do you think I will find the length of C? Pythagorean theorem. And that's why you see this right here. I know it's cut off from my screen, but you guys can see it clearly. Square root of, well, the distance from here to here squared plus the distance from here to here squared. And that's your Pythagorean theorem. So, and that's what that blank place is. Or you can use Pythagorean theorem. All right. Yeah, I butchered Pythagorean. Note there's a P, a Y, TH, and some G in there somewhere, so maybe hard. Mine's the Pythagorean. All right. So as you can see here, let's find the component form and magnitude. So we need to find the component form and the magnitude of the vector V of the initial point -2, 3, and terminal point -9, 7, or -7, 9. So I'm going to come over to this graph here. I can get as much in the screen as I can. So -2, 3 puts me here. -7, 9. So our vector is here. When you have a graph, it is very easy to calculate this. Very easy. Because all you're going to do now is find the magnitude and direction of this. Well, how far, starting here, now remember, we start from here. You got to know where you start at. Starting from here, what direction, left or right, did we go? Left, how many? 5. So it's -5 to the left. Up or down? 1, 2, 3, 4, 5, 6. And so you write it like this. What's the component form? -5, comma, 6. What's the magnitude? Well, we know A and B, so what do we do with both of those in order to figure out the magnitude? There you go. So it ends up being. In the calculator, I recommend doing that, by the way. So there's that. When you have the graph, it's pretty nice. But if we don't have the graph, you draw one, but it takes some time. We just go ahead and find the distance. What's the distance, guys, from -2 to -7? What is the distance? There you go. How'd you come up with that? -7 minus -2. And then what's the distance from 3 to 9? How'd you come up with that? Oops, sorry. So basically it ends up being the x2 minus x1, comma, y2 minus y1. Does that sound familiar? This should all be very familiar to you, because those are the equations you use in order to find slope. Except now all we're doing is this. Is that right there. All we're doing now is taking the difference of x's, comma, difference of y's, and putting some fancy little brackets on the side. That's it. That's it for component form. Magnitude, square both those numbers, add them together and take the square root, and now you found your magnitude. So you got from there. All right, so that's just from points. If they give you points, that's what it looks like from there. But what happens when we add two vectors? Well, guys, this is what we've been doing all this morning. With that bearing stuff, this is what you've been doing already. Hey, we're running in a direction south 42 degrees east. All right, so I'm here. Then I change direction over here to do this to finish off my route. What's the total distance, or where's from the starting point? You connected two vectors together there, guys. The one segment going 2 kilometers connected to another segment going 3 kilometers. You've connected them together. And it has to be, when you connect them, they have to be head to tail. Or head to tail, whichever one. It doesn't matter which one, but they have to be connected tail to tail. So, as you can see here, when we add them together, I'm going to draw the u vector, which basically, to help you out, is over 1, 1, 2, 3, up 3. So I'm going to go ahead, start at here, go over 1, and up 3. And we're going to add it to v, u plus v. V goes down 1 and to the left 2. So from here, we go down 1 and left 2. And so we have that there. So this is u added to v. Because again, to connect these, you have to go from head to tail. And so that's how you connect vectors using the graph. And again, we used its components to figure out where it's at. Okay? Let's move on to the next one. What about the negative of it? Well, as you can tell, when we have the negative, it's just going the opposite direction. Same thing with slope. If you went from a positive slope to a negative slope, where you're going from right and up now to left or up. So you're going in the very opposite direction that you're doing. So with that being said, we go ahead and say, all right, with UV, U minus V, I guess it's using the same length as the same one above. Draw a diagram of U minus V. So, again, what we started off with, this is U minus V. Well, in our first problem, plus V took us to here. But we got to go the very opposite direction of it. We don't go down 1 and left 2. We go right 2, up 1, or up 1, right 2. So basically, our negative V looks like that. Which makes what we're trying to calculate, that's our resultant. So as you can see, with negative, we just flip it. Okay? And basically, that's the same thing that's going on here. Is U minus V looks the same. All right. So let's go and look at some problems here, guys. And what it basically shows you is basically what we talked about earlier, which is, hey, if U is equal to AB and V is equal to CD, then if you add them together, you just add their components up. You subtract them. If we amplify them, if I make it twice as much, you got to remember, guys, when we amplify, look at the top there where the K is. That's any number. If I double V, that means it's 2 times the X and 2 times the Y. That's what that basically means. You distribute the amplification out throughout. Right, so let's go let U equal negative 5, 2, and V equal negative 3, negative 6. So we add them together. So we go over here and say negative 5 plus negative 3, because that's our X components, plus 2, or comma 2, plus negative 6, and that's our Y component. And you just end up with that there. You add the X's and you add the Y's. You add the X's and then you add the Y's. For B, you subtract the X's and you subtract the Y's. So note there is a minus sign here. So when we do that, we say, okay, negative 5 minus negative 3. You get 2 minus negative 6. That minus sign is still there, and all we're doing here is we're just subtracting those two components together in the order that they are. So you end up with negative 2, comma 8. And the last one. So the last one takes an amplification to them. So what I recommend first is just doing the multiplication part first, and then doing the subtraction part second. So let's go ahead and amplify U by 2. So you take all those numbers and just multiply them times 2. And we're going to subtract that from 1/3 of V. And so you have this. So you have negative 10, 4 minus negative 1, negative 2. And so we go ahead and perform that calculation. Negative 10 minus negative 1, comma, 4 minus negative 2. Question about vectors. A component form is a simplified of saying, hey, here's the vertical, here's the horizontal. Here's how far we went to the left, here's how far we went down. Here's how far we went to the left, here's how far we went up. Here's how far we went to the left, here's how far we went up. So those just tells you basically a way of saying, hey, we're not going to draw the line, we're just going to tell you how you get there. In simple east, north, west, south direction. That's it. Okay? On that one. Vectors typically don't get that hard. After a while, when you start doing them, you're like, okay, it's this simple. It's as simple as just adding and subtracting numbers. It's going back as simple as finding slope. Okay, and that's all it is on there. And so the rest is going to be practice. But we got 8 minutes left in class, so we'll just go ahead and stop there, guys.